Hello everyone, I am Yanru, your teaching assistant for this course, Information Architecture and Design. Today I am gonna briefly talk about SPSS, a software for analyzing data. Maybe some of you have heard about SPSS or even used it before, so here let's just briefly recap it. SPSS is a software developed by IBM, for editing and analyzing data in behavioral science. Why do I say it's in behavioral science? Because in behavioral science, we normally handle a relatively small amount of data, like hundreds of cases or thousands of cases. For millions of cases, SPSS cannot process it or compute it. It's too big for SPSS. SPSS is very popular. I have been using it for my own study for 4 years and I really like it. The strength of SPSS is that it has a variety of statistical tools for us to use, and these are very commonly used statistical tools. And also, there are two ways to analyze data. One is by clicking the various buttons provided in SPSS editor view, and the other one is more technical. It is also the one that I'm learning right now is to write syntax. Basically, is to write codes in the SPSS syntax editor. But SPSS also has a big weakness. That is, there is no calculation shown to the users. So SPSS has their own way to define how each computation should work. So if you want to change some of the by default settings, you have to learn how to write the syntax to change it. Clicking the buttons doesn't allow you to change how the calculations can be done. That's why I'm learning the syntax. But this may be more applicable to more advanced calculations. For some basic ones, it's a standard universal. Okay, so let me give you some examples of what SPSS is capable of doing. For example, describing variables separately. When we get a data set, normally we want to first have a sense of what this each variable is look like, so we can plot some graphs. SPSS can very easily plot such graphs, and there are different graphs settings available for us to do. And we can also use SPSS to manipulate data. What do I mean by manipulating data? For example, you want to reverse code some of the items. If you have a Likert scale from 1 to 5, sometimes you want to change the 1 to 5 and change the 5 to 1, change the 2 to 4, and change the 4 to 2. This is called reverse coding in Likert scale items. SPSS can very easily do that. And also sometimes you want to sum up some certain variables. For example, from variable 1 to 4, if they are describing the same construct, you would want to sum them up and maybe divide them by 4, and you can get the average of the 4 variables because they are describing the same construct. And SPSS can also help us to compare multiple variables. So for example, when you draw a sample from the population and you want to compare how this sample is different, or you want to say that your sample is representative, so it should be the same as the population. So you want to compare the means and the standard deviations of the sample to the whole population. Or if you get two different groups, for example, one from the female students and the other from the male students, and you want to compare how they are the two groups are different, SPSS can also help you to do that. The last is associations between variables. So you want to see how two variables are correlated to each other. The difference with one variable can cause, can influence other variables, and or maybe even more variables, how some of the changes in some of the variables can influence one single variable, that is called multivariate analysis. And of course, there are also more statistical tools that SPSS offers, but these four are the most commonly used analysis that we are use as a start. So this is the SPSS interface. When you open SPSS, this would be the data editor interface. And if you see, this is called the data view. So in each variable and in each case, the exact data is shown to you. And this is called variable view. From this view, we can change the name of the variable, and we can specify the values and how you want to handle the missing values. And you can also specify what kind of variable it is. For example, is it nominal? Is it scale? Is it ordinal? Because the different measures of each variable would affect how it can be analyzed. If it is nominal, it can so you cannot use it for example, correlation. Most of the statistical tools in SPSS are developed to analyze scales like ordinal or interval or ratio data. All right. So just now I mentioned that there are two ways. Other than clicking the buttons, there is also the syntax editor that you can write the code to change, to do the analysis and to get the files and to save things, etc. So this is how you can get the syntax editor out. By default, if you open the SPSS dataset, it can only open the data and the output. For syntax, you have to manually get it out. So this is the output viewer. So whatever analysis that you have done, the result would be shown in this output viewer. You can click and save the content in the output viewer to the Word document or Excel. It's very convenient. Okay, so when we get a data set, how do we start? After collecting the data, if you don't have it as the online, you have to manually enter the data. SPSS also can import the data from Excel. And you have to check the data. You have to do some basic checking to see how many cases are missing and how many variables, things like that, and inspect the variable types that I mentioned. Because when you input the variables, sometimes SPSS can make errors, or it can just universally say it is categorical data, and you have to manually change it to scales in order to analyze them. And you have to specify how you want the missing values to be replaced. Do you want to replace the missing value by the mean of other cases in the whole group, or you want to replace the missing value with the mean of the surrounding values? And after some initial inspection, we can go on to analyze the data. Normally, what I would do is I would plot some of the graphs to see how the variables are distributed. And then I would choose the appropriate test. And after seeing the results, I would interpret the data and reconstruct the tables to be put, for example, as APA style, and put it in my paper. Now let's do a hands-on demo. Download a file called examanxiety.sav from NTU Learn. .sav is the by default file name for SPSS dataset. This is a free dataset I downloaded online. Okay, so let's double click. If you have SPSS installed on your laptop, by double clicking, SPSS can open it. The other way is to launch SPSS first, and then you import the data. Okay, it takes a while. Okay, this is how you can open data, or you want to enter data from scratch, then you just click on File, New, and New Data. Okay, or you open an existing data file, you open Data. Okay, as I mentioned just now, SPSS automatically opens two viewers. The first one is this, it's called Editor View, and the other one is here, it's called Output Viewer. Whatever you do with the data, you analyze it, you plot it, the result would be shown in the Output Viewer. Okay, so now let's take a look at this Editor Viewer. This is a set of data, and we first come to the variable because I didn't collect this data, so I'm not very familiar with it. Now let's roughly figure out what this data set is about. Okay, this code I think is the same as the numbers, so it's really not really useful. The second, revise, is the time spent revision. I don't know if you look at the revise, it's some numbers. So it may be minutes, it might be hours, it might be days. I don't know, let's just assume it's hours, all right? And the other one is exam performance. I guess that would be in scores. So the higher your performance is, the better it is. The next variable is anxiety. So they might have some items to measure your level of anxiety before taking the exam. And the last variable is gender. Okay, and we can see from here, 1 refers to male and 2 refers to female. This is where you can make notes in case you forget. It's for easy reference. The other one I want to draw your attention to is here, measure. This column is really very important because if you see this gender is a nominal variable, it is because you only have two values. One is 1 female, the other one is 2 male. Oh, sorry, 1 male and 2 female. But for anxiety and exam and the revision, time spent on revision, they are scale measures. Most of the SPSS computational tools are designed for scale variables. And when you enter the data or when you input the data from Excel, you have to carefully pay attention to this cell that you want to change the value to scale if it is indeed scale. If you just put it as nominal, SPSS is not able to compute it. It will return you with an error message. Okay, so everything is good here, and we come back to the data view. Normally, when I get a data set, I want to have a rough sense of what this data is about and how it is distributed. SPSS can easily do that. Let's see how it is done. Click on Graphs and Legacy Dialogs, and I want to see the histogram. Okay, I want to see how the time spent revision and exam performance and exam anxiety. Oh, sorry, I cannot select 3 at one time, so I have to select them one by one. Okay, let's see exam anxiety. And I want to display the normal curve. Click on OK. So you can see in the output viewer, this is it. The students experience quite a lot of anxiety. They were quite anxious. Okay, we do the same for the other two histograms. and we put this exam anxiety back, and we put exam performance. Click on OK. It follows like a very close normal distribution. And we do the same for time spent revision. Okay. This one, the students roughly spend 10 to 30 hours. Most of them spend 10 to 20 hours. There are even people spend like 100 hours, which is very good. Okay, so I also want to see, because we've got male and females, so I want to see whether the data set is equally distributed among the different genders. How do I do that? It's not graphs, but analyze. Descriptive statistics and frequencies. Okay, I click on frequencies and I click on gender. Put it in a variable and I click on OK. So this is the table. As you can see, the frequency, there are in total 103 respondents. Among them, 52 are male and 51 are female. So you can say that our data set is quite balanced in terms of gender. Okay, when I look at the different variables, my guess about the research hypothesis is, for example, do female and male differ in their exam performance? Do they differ in their anxiety level? Do they differ in their, what is the other one? Time spent on revision. The other hypothesis might be, does the time spent revision correlate with the exam performance? Which means that the longer you spend on revision, the better your results would be. And the other one might be, does anxiety affect your exam performance? If you get too anxious, your performance would be lower. And I have another more advanced hypothesis, which is the more where the anxiety level would become a mediator. So when you spend time on revision, the more time you spend, the better your results would be. But if you experience a high level of anxiety, it will lower your experience, your exam performance. So which means that the exam performance is also dependent on the level of anxiety that you experience. If you spend more time and your anxiety level is low, you are relaxed, then you get better results. This is an advanced statistical tool. Okay, I'm not gonna show you today, but I'm gonna show you how to do the correlations and compare the means. Okay, first we want to see whether males and females differ in their exam performance and everything else. How do we do that? So you can see I have listed 5 research hypotheses here. They are listed on the slides. Basically, the first 3 research hypotheses are concerned with whether female and male differ on certain aspects. And the last 2 research hypotheses are concerned with the relationship between the time spent on revision and anxiety on the exam performance. I think the more time you spend on revision, the better your performance is. But the more anxious you are, the worse the performance is. So they are negatively correlated with each other. Okay, so now let's test our first 3 hypotheses. How to do that? Click on Analyze, Compare Means, and Independent Samples t-test. So you see I have already put it here. Let us do the time spent revision first. So put time spent revision into the text variables and put the grouping variable as gender. I put it back and gender. And now we need to define the groups. There are two groups in the gender. One represents male and two represents female. So we just put 1 and 2 here and click on continue and click on OK. And let's check the table, okay? So here is the mean for male and mean for female. So one is 18 plus, one is 21 plus. So female did do better than male on the time spent. They spent more time revising for the exam. However, we can see that the results are not statistically significant. So the conclusion is that they don't statistically differ in their time spent on revision, right? So we do for the other two compare means, independent samples t-test, and to replace the time spent with exam performance this time, and we see whether they differ in their exam performance. Exam anxiety, sorry. Not really. As you can see from this, the mean is very similar. Both are around the 56.50. So we can straight away reject this hypothesis. No need to even look at the significance level. Okay, so we do the last one. Compare means, independent samples t-test. Exam anxiety. Yes. Their exam anxiety are also very similar. So we can also reject this null hypothesis. I have formulated 3 useless research hypotheses that were rejected. Never mind, let's go on to the next two. How to do the next two? The next two are about correlation. So we go to analyze, correlate. Since this is the relationship between two variables, right? The fourth research hypothesis is about time spent on revision and performance. The fifth one is about anxiety and performance. So it's bivariate. And we put time spent, revision, and exam performance. And we use Pearson R. This is the most widely used correlation coefficients. And the test significance is two-tailed. Everything is great. Check options. We can ask for the means and the standard deviations. And this is very important. SPSS can flag the significant correlations for you. Okay, so we click on OK. And let's look at the results. This is the Pearson correlation. Just now I said we check the flag, right? So here, this is called the flag. And as you can see, the significance level is statistically significant. That's a good point. And then we can see the correlation is quite strong. It's almost 0.4. So we are safe to say that the more time you spend on revision, the better your performance is. So these two variables are positively correlated. And we go on to examine the next research hypothesis, do the same thing, correlate bivariate. And we replace the time spent revision with the exam anxiety. Okay, still the same thing, Pearson R, flags significant correlations, plots the means and standard deviations, continue and OK. Wow, great, we've got another significant result. And And yes, as we thought, the correlation is negative. So it means that the higher your anxiety level is, the worse your performance is. And this is also a strong correlation, 0.441. All right, so basically that's it. Of course, SPSS can also do other more advanced statistical analysis, but that's outside the scope of this tutorial. Yeah, that's all for now. The documentary on SPSS is very comprehensive. So if there are anything you don't know, and you can just search on Google and just say how to do this and do that in SPSS, and I'm sure you will find a lot of helpful tips.